Good morning. Our last topic of the year is working with things known as conics. And my first goal is to give an overview of what conics are, why they're called conics, and then start taking a look at particular conics, some of which you already know a lot about, but we might be looking at them from maybe a little bit different perspective. Um, so here we go, conics. We can look at conics a variety of ways. First, I want to consider the geometry of what a conic is, and then talk about our first one in terms of a locus definition. Well, why are things called conics? It really comes down to this. If we would have a cone, or maybe even a double cone, and I would slice it with a plane, in geometry, the intersection part creates the conics. So let's think of a single cone here. So this is a cone. And if I would slice it with a plane, you could see that I could slice it straight across. And if I do that, what would happen is I would get an intersection that's basically a circle. And a circle is one of the conics. If I would take the plane that I sliced this cone and angle it just a little bit, I'm basically going to get what's known as an ellipse. So those are two of the most very basic conics. Now, if I do a few other things, I can get the other conics, such as if, it's going to be harder to draw this, if I would take this plane that I slice it so it's parallel to the base, if I tilt it, it becomes an ellipse. But if I tilt it far enough, what I'm going to get is a curve that becomes basically a parabola. And there are some very nice pictures of this in section 11.1. Okay, so you want to study the section, maybe even go online to look at some of these, but that would be the parabola. Now, to get the final conic, we basically need kind of a double cone. And if I happen to take that plane, again, if it's parallel to the base, it's a circle. If I rotate it a little bit, it's going to be an ellipse. If I rotate it all the way to where it's parallel to maybe this axis right through here, I get a parabola. But if I rotate it a little bit more than what I would do for the ellipse, but not as much as I would do for the parabola, it's going to hit both sides of this cone. So I get basically what you would call is a hyperbola. Again, that would continue to go down here to here. That'd be one part of the hyperbola. And the other part would be here. Okay, so again, read the section, or at least study the pictures in section 11.1. You'll get a good feel for what the geometry of the conics are. Now, the other part of the conics is this idea of locus. In geometry, when we refer to a locus, we're talking about a set of points. And then there are requirements on that set of points. And the first of these that we're going to look at is, of course, a circle, the purple one. What is a circle? Well, hopefully, this is the one you're most familiar with. And that's why some of the problems that I'm going to give you go all the way back to 2.3, even though they might not be mentioned in your problem set packet. But I'll put these up here before we leave today. A circle, you might remember from geometry, is a set of points. So if we look at the formal definition, it is a set of points we do want them in a plane, equidistant, from a fixed point. So, let's take a closer look at that. It has to be in a plane. We have this equidistance. We have a fixed point. So let's start with the fixed point. There's my fixed point. And of course, we call that the center. So there's my, maybe call it C. That equidistant, you might remember, let's say it's this far. That's a point in the circle. or then this far. But if all those distances are the same, I keep finding all of those. Might take a while because there's a lot. I basically end up with a circle, and that fixed, or that equidistance, of course, is called the radius. Make that a little straighter. Right? So, we know what a circle is, the set of points in a plane equidistant from a fixed point. Not much to it. The two very important characteristics of a circle are the center and, of course, the radius. Now, we tend to focus kind of on the third way of thinking of conics, and that is by an equation or a function. Now, if we put these on an xy axis, the equation for a circle could be considered to simply be x squared plus y squared equals r squared. Again, standard, you've seen that before. If for some reason we move the center so it's not right at the origin, and move it left, right, up, and down, we know that we have some translations. And a very common way to write that would be to use the center as being HK. So if HK is the center, we know that this is the translation of the general conic x squared plus y squared equals r squared, and we move it over h and up or down k. So what we're going to be doing here is kind of the same old thing that we've done with so many different functions in this course and previous courses, is we want to be able to understand this topic graphically, so we know what the graph looks like of a circle. We want to know what it looks like in terms of an equation, so that's the function. And we also want to know what it looks like in terms of the stuff, its characteristics, its center and radius. So most of the problems that you're going to see are basically asking you about those types of things. So let's just get to an example. Let's say we want to find the equation of a circle. With center 1, -2, and through the point for -2. Now, as always, a sketch is not a bad thing to do. So if we want to sketch this function, of course we can. All right, but what we can do now is realize that I have my center, so there's my h and k. I somehow need the radius. Now, if I plot these 2 points, we can see that they're both on the y line of 2. So they're only 3 units apart. So r is 3. Sometimes it's not quite that easy. We have to actually find the distance between those 2 points. Well, once I have it, my equation is going to be x minus the x value, which is 1 squared, plus y minus the y value, which would be plus 2 squared. You could keep it as 3 squared, or of course you could put 9. And there's my answer. It could be as simple as that. But I knew the stuff, and I wrote the equation. Now, there are a variety of other things that you might have to do. Maybe I would actually give you the circle and you have to write the equation. Or I might even ask you to maybe, what if I give you the equation and you have to find the center? Let's do something like that. So let's come up with a function. Let's say we have x squared plus y squared. And I could make it a little bit more challenging. Let's say plus 2x plus 6y. And let's say that's equal to 10. And let's say 16. Now, somehow I have to transform this equation into this. And when we do that, we have to make use of some algebra that you've learned in previous courses, known as completing the square. So in completing the square, I basically need to look at the x and x squared term, so these two. And if I complete the square on that, remember it's really three steps. Take half the x coefficient, square it, and add it. Half it, square it, add it. Half it, square it, add it. So we got x squared plus 2x. Half of that is 1, squared is 1, add it, we get 1. Now in terms of the y squared plus 6y, same thing. Take half that, square it, and add it. Y squared plus 6y plus half it, 3, square it, is 9, and add it. Now, of course, what we're going to do over here is also add the 1 and the 9. Okay, that's required. And so now I know that this is a perfect square because I made it a perfect square. That's x plus 1 squared. Same thing with this trinomial. It's a perfect square. Y plus 3 squared. And of course, we put all these together, we're going to get 26. So because of that, I can now answer my question. The center would be -1, -3, and the radius is radical 26. So for our first conic, and this idea is going to be repeated, that we're either given the particulars of the situation and we have to write the equation. We could be given the graph and we have to write the equation. Or we could be given the equation and we have to know the stuff, the particulars, which in this case are going to be the center and the radius. The problems from section 2-3 that you'd want to work on would be 9 through 47 odd and 51. Maybe every other odd and 51. Again, this is not in your problem set sheet. I think this is going to be mainly a review for you. All right, but section 2-3, those are a few problems just to get comfortable. In just a few minutes, I'm going to post the second part of this, which will look at the next conic. And really over the next about week and a half, every other day we'll look at a new conic. Eventually we'll bring it all together with a little bit of trig. But this, in terms of all of the different topics we've had this semester, is probably the least amount of trig that we will see. Before you know it, we'll be having kind of a couple short quizzes, worksheets, and of course a big test over these conics or quiz, and then eventually an exam. So it's going to go quick. Stay focused. If you have any questions, please let me know. I know that you're also currently working on the latest test, so as soon as you get that completed, send it to me. Everything you've sent to me so far has been great. I've been able to read it and grade it. Hopefully you're noticing those grades on Blackboard. Once again, if you have any questions concerning anything that we've done in the past or that we're doing currently, please let me know.